question for in this unit. And our goal for it is to simplify exponential expressions and determine the value of exponential equations. Okay, so what this means is we're going back to some of our exponent laws, and this time I'm going to list a few more of them. There's approximately 8 in total. Now we're only going to be responsible for 4 for today's lesson. All right, so first of all, exponent laws apply to both numerical and variable bases, which means numbers. So our bases could be numbers, or they could be variables like x's, y's, m's, whatever. Okay, so it goes for both of them. Now, in order to use most of the exponent laws, you are required to have the same base. Okay, so remember we talked about bases and powers, so we need to have the same base in order for most of the exponent laws to work. So the first is multiplication. So if I have two bases that are the same, so you can see the two bases here. The two bases are a. One of them is to the power of n, one is to m, and I'm multiplying. So when I'm multiplying, what I do with the exponents, I only keep one of the bases and I add the exponents together. Again, that is a review of something you've done before. Division. Again, if my bases are the same, okay, as they are here with a again, and I'm dividing, I take the exponent n and m and I subtract them. Now sometimes this exponent law is written like this because often we divide in a vertical manner. And sorry, that's kind of crappy. But sometimes we do it in a vertical manner, but the same would apply. I would still go n minus m. The next law is a power to a power. Now for this I don't need like bases. Okay, so I have a to the m to a number, and I also then take that and have it to another power. And in that case, I multiply the two powers together. And the fourth law is the negative exponent. And we've looked at that when we did our prerequisite skills. And we know what we do is we reciprocate the base. We don't change whether the base is positive or negative. What we change after we reciprocate is the power. The exponent then becomes positive. Okay. Now, when we're working with these, that it's sometimes possible to apply the exponent laws. Actually, it should be laws. So I'm going to put laws in here. Okay, and I'm just going to highlight that. You can put an arrow to bring yours in. You can apply the exponent laws in a different order for questions. Okay, so sometimes if you're using two different laws, you can apply them in two different ways. Okay, so let's look at the kinds of questions that you're going to be responsible for. Now I'm just going to put, again, the screen up, so I'm just looking at one at a time. So this one here, you can see my base is 5 in both cases, and the first one is 5 to the 4th, and the second one is 5 to the negative 2. Now, because the bases are the same and I am multiplying, what I do is, and because this is a note, I'm going to write it down this way. I take the powers, the 4, and I'm going to add the negative 2. Okay, now if I'm going to write it like this, it's important for me to keep this calculation up in the exponent area and not bring it down with the 5. Now, if I do that adding there, I end up with 5 to the positive 2. Okay, so simplify, I'm not after an answer. I don't want 25, I want 5 squared. The next question, you can see this time I have variable bases, both of them are m, and I am dividing, which means I'm going to take the one base, the m, and I'm going to take my exponents and go 7 take away 3. And you know that 7 take away 3 is a 4. If I look at the next one, there's a few different things going on here, so I could calculate it a couple different ways. I think what I am going to do, because my bases are both negative 6, I'm going to use the division law first rather than doing the flipping with the -1. So my base is -6, so I have to have a bracket around my base when it is a negative base. And I have 2, and I'm taking away a -1. Now watch out for your integers here. So I'm taking away because of the exponent law, and my exponent, my power here is -1. So really what I have here is 2 plus 1. So my answer is -6 in a bracket to +3. All right, and the last question, a little bit more again, oops, sorry, a little bit more to it. And for some reason, the screen doesn't want to come down for me. The next one you can see is a little more involved. Well, now, when I have something a little more involved, what I like to do is I like to take the numerator and apply the exponent laws there, and then the denominator, and then apply a further exponent law. So I can see in my numerator, both bases are a. I'm multiplying, so what I do is I'm supposed to add those exponents. So if I write it down, and I will write down every single step here so that there's no question. And on the denominator, I have power to a power. So I have -2 times 3, which is -6. I end up in my numerator as a being 2 plus a -5, so a -3, all of that divided by a to the -6. Okay, it doesn't matter how many steps you do here, but the more steps usually means the more success you will have. Now my bases are the same and I'm dividing, which means I'm supposed to subtract my powers. So when I do that, so now my pen wants to move where I don't want it to, would be a to the power of -3. I'm going to subtract because I'm dividing -6. Again, watch your integers. So I have -3 actually plus 6, so it ends up to be a to the +3. Okay, not too bad. Now the next questions are actually just as easy as what we just finished doing there. So let's take a look at them. Now in this case, they have assigned numbers for our variables. Now you could substitute the numbers in right away and do it that way, or we could apply the exponent laws to the a's and b's and then substitute in. And it actually is easier to do it that way rather than substituting the numbers in first. So let's try this. Now the brackets here tell me that it's a to the -2 times b times a to the +3 times b to the +4. So what I'm going to do is I'm going to take the a's, and so I'm multiplying, so I'm going to have a -2 plus a 3. The b is going to be, oh, I don't know what this one is. Oh, if it's not showing, then it's to the power of 1. So it's going to be 1 plus 4. Really watch out for that. They often, well, we don't put a number 1 when we have a power of 1. Then when we do that, we end up with a to the power of 1 and b to the power of 5. Now that's much easier to substitute in because I'm just substituting two numbers in, and that's what we're going to do first. So we end up with a, which is 1, and it's to the power of 1, so I don't have to put it, and b, which is -2 to the power of 5. So 1 times anything is just whatever it is. So -2 to the 5th. So my answer is going to be negative because I have an odd power. -2 times -2, so I have a 4 times a 2 times another 2. So I'm looking at 32. Okay. And our last question, same kind of thing here. We're going to take it and we are going to simplify it first. So when I simplify this one, Again, you can see I have A's, B's, and C's in this question. So the first thing I'm going to do after my pen behaves itself is I'm going to take my A. It's to the negative 4. I'm dividing, and because there's an A here, it's to the power of 1. So I'm subtracting 1. B is to the power of 5. And because I'm dividing, I'm going to subtract 3. C is to the power of 2. I'm dividing and I'm going to subtract, oh, there's another one of those ones, minus 1. Again, I have A to the power of negative 5, B to the power of 2, and C to the power of 1. Now I could substitute in here or I could rearrange it. The negative is going to flip. So right now it's on the top in a sense. So it's going to be on the bottom. Oops, that doesn't look very nice. So I'm going to put A to the 5th on the bottom. B squared's on the top, and so is C to the power of 1. Now when I substitute my numbers in, I have B, which is negative 2 squared, times C, which is 3, over my A, which is 1, to the power of 5. When I do that question, negative 2 squared is going to be 4, and 3 is obviously 3. And 1 to the 5th, well, 1 times itself 5 times is still 1, so my final answer is 12. Okay, next up will be word questions.